Hi and welcome to my part 2 of the lighting tutorial series, and in this one we're going to take a look at the light modes. Let's have a look. So here we are back in Unity, and all I've done in this scene, this is just carrying on straight from where I left off from the previous lighting tutorial. I've just gone ahead and created one type of each of our primary lights, so we've got a directional light, a spotlight and a point light. Now in this tutorial I just want to look at one thing in particular, and that's going to be the mode section, and what does this actually mean and what does it do. So each of these lights have this feature in common. They each have a mode. So our directional light's got the mode, our spotlight's got the mode, and the point light's got the mode. And if you click on real time where it says mode, you'll see that there's actually 3 that we can choose from: real time, mixed and baked. And this is what we want to have a look at. We want to know what the differences are between each of these and where we can leverage the power of each of these in our game. So let's start by having a look at real time. At the moment all of our lights in the scene are currently set to real time. Back on the directional light, what does a real time light actually mean? Well, all the calculations for that light, all the shadow calculations, all the brightness values are all calculated every single frame of your game. Having a real time light essentially means that everything in your game is kind of dynamic and will react to that light when it changes. And if you change that light in your scene, then that will instantly have an impact on what you're seeing in your visuals. And you can certainly notice this in games, particularly where the light is constantly changing. Let's say you're playing like Ghost of Tsushima and you're running around the environment and it goes from night to day. Well, that night, daytime, nighttime cycle is all real-time lighting. The lighting is able to change. You can see that in our scene here. So if we go and select our directional light and we rotate it, imagine we were running this in real time and we were playing our game. The very fact that it's able to generate these shadows is all being calculated every frame while the game is being played. Which, as you can imagine, on a very large scene can be quite computationally expensive. Which is why it's really kind of like your high-end hardware devices that are running real-time lights. Now real-time lights have a lot of benefits. As I say, they're used for like day and night cycles or any situation where the light needs to change. If you imagine the spotlight, for example, is a candle, if I go ahead and turn these 2 lights off, so all the lights in the scene are set to real-time. But if I'm just going to make this a little bit brighter using the intensity, imagine this was coming from like a street light, for example, and there's some kind of weird power cut in your game and you were turning your light on and off, then that the very fact that it's illuminating will be all computed at runtime every single frame, as well as the shadow that's produced on the ground. I'm going to go ahead and turn those all back on. And then lastly, real-time lights, you don't have to change the values of the lights in order to benefit from the real-time lighting. Also, objects in your scene that are movable will also have the benefit of being able to create a shadow that's accurate to your lighting and not kind of baked into your scene, as we'll cover later. Dynamic animated objects will cast a real-time shadow and have proper illumination as it moves through the scene. Go ahead and undo that. So the next lighting mode we can go ahead and take a look at is baked. We're going to leave mixed out for a minute because that's a little bit of a hybrid, and you kind of need to understand what real time is and baked is before you can understand what mixed is. So we'll go ahead and set our lights to baked, all of them. You can multi-select and do this too, which is quite handy. So what is baked lighting? So baked lighting is when the editor, well, in this case Unity, is actually performing all the calculations for the light in the editor, and then it stores that data as lighting data to disk, which is saved as a texture, which is then reapplied when you go and play your game and illuminates all the surfaces using those saved textures. As you can imagine, doing it this way is very lightweight, and it's why it's really optimal for use on like mobile games and web deployment, or any situation where you don't need some computationally expensive real-time lights. So when you set a light to baked, you're effectively telling Unity, the editor, that this light isn't going to move in the scene. And what's good about also baking your lights is you also do benefit from the indirect light, the bounce light that you get when a light is cast throughout objects in your scene. Bake lights are very much going to reduce your shader cost at runtime as well as your shadow cost. And actually in the next tutorial we're going to have a look at actually some settings for baking lights, and we'll be able to see how to do that process. But just understand that these lights can all be set to baked, and we can effectively save the values of these lights and the shadows and the illumination that they have on the surfaces into texture maps to optimize our game. So finally then, let's have a look at mixed. So we're going to go ahead and we're going to go and set all these lights to mixed. Select my directional light. Mixed lights are very handy because, as the name suggests, it's a combination of both real-time and baked together. So you can have all the benefits of a baked light, but then also at the same time the ability to have a dynamic shadow for movable objects using the same light. Or you can have it so that the light contributes to real-time direct lighting, but then will also contribute to baked indirect lighting. And indirect lighting is kind of like your bounce light off an object. So once the light hits the surface and it bounces, the illumination that is contained within that second bounce is then stored to your texture map. So as an example, we've set our direct light here to mixed. We could go ahead and set this one to baked. So the light cast from this particular spotlight is going to be baked into our scene, as well as the light coming from our point light we're going to set to baked, and I'm going to quick tweak this values ever so slightly so it's not overly bright and make it a different color. I'm just going to change some properties of these lights. We can have a look at what's going on and do a very quick bake. We're going to actually bake some lighting. I'm going to leave this one as mixed and we can see how it acts. Now, the way we set up our geometry is quite important here too. So in order to see the mixed light working, one of our objects is going to have to be like a dynamic object. It's going to have to be being able to have the ability to move around. But the ones we want baked into our scene, where we can tell the engine that these aren't going to move and these can be incorporated into the light bake, is we're going to mark it as static. So everything that we don't want to move in our scene, we're going to mark as static. So this green ball, static, my illuminated ball, static, as well as all the walls and the floor, all static. So these are going to be included in my light bake calculations. Now I'm only going to do a bake just to show how mixed lighting works, and as I say, in the next one we'll have a look at actually light baking. I've gone ahead and done the bake. Remember, this light is mixed, so this means it's benefiting from real-time and baked settings. So it's going to cast real-time shadows from this light and real-time illumination, but it's also going to bake in the indirect light from this light. The spotlight is set to baked, so now when we move the light you can see that the illumination on the floor doesn't change because we baked in the lighting. And the same is going to be for our green light, although we can't really see it because of our powerful emissive material that we had down here, which coincidentally, as you can see, now baked in to our light textures. And you can see one of our light textures there. So the surfaces in our scene are all getting their lighting information from our light map. So I'm going to go ahead and move that back. But the object that we set as dynamic that's going to be benefiting from a mixed light, so as we move it around, this mixed light is casting a shadow that this dynamic object is benefiting from. You can see that when we turn it off, that the light settings for that light, we're only getting the indirect light baked in, and we're no longer getting this object illuminated or the shadow. We need our mixed light enabled to do so. So you can imagine that this ball is your character, and you're walking around your terrain and you're getting all the benefits of your sunlight without all the things in your scene that don't change and don't move have all baked in direct and direct lighting, and the shadows baked into them as well. So those are our three primary light modes: real-time, baked and mixed. Real-time, as I say, is just going to be everything is computed at runtime, every frame of your game, all the lighting, all the shadows. And then baked is going to be where everything is committed into a light map and it doesn't change, and anything that you've got that's moving in your scene won't be affected by any lights and won't cast a shadow. But then when you incorporate the power of a mixed light, you have the benefits of being able to bake static objects geometry into your scene, so you get the nice lighting from the indirect mixed light. And then the mixed light is going to provide the kind of like the best of both. It's going to allow us to have our dynamic objects in the scene, like your character, and have a real-time shadow without all the other objects in the scene that are going to be baked to save on your rendering cost. So there we are. Hopefully that's given you some good understanding of what the different light modes are and how to use them in your game. In the next one, we're going to have a look at actually baking some lights and looking at some light mapping settings in a little bit more detail. Till then, see you later.